Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will explore the key concepts involved in the control principles of AC motor. Our lesson will cover the following three main topics. In this lesson, we aim for you to accurately identify key parameters of AC motors, such as rated power, rated voltage, and rated current. You should also understand the basic principles of star connection and delta connection, and be able to select the correct wiring method based on the motor model and power supply voltage to ensure proper motor operation. AC motors are devices that convert electrical energy into mechanical energy. When selecting and using AC motor, it's important to understand several key parameters. Choosing the right motor parameters ensures smooth operation and enhances efficiency. Proper wiring methods ensure safe and efficient operation, improving productivity and safety in industrial environments. First, let's study the key parameters of AC motor. The main parameters of AC motor include rated power, rated voltage, rated current, rated speed, moment of inertia, maximum torque, response time, position, and speed accuracy. Rated power. This is usually measured in kilowatts or watts. Rated power refers to the maximum power that the motor can continuously deliver under rated voltage and frequency. Rated voltage, measured in volts. Rated voltage is the operating voltage at which the motor can function optimally under its rated power. Rated current, typically measured in amperes. Rated current indicates the maximum current the motor can continuously handle under its rated power and voltage. Rated speed, expressed in revolutions per minute. Rated speed represents the highest speed at which the motor can continuously operate under its rated power and voltage. Moment of inertia, usually measured in kilograms square meters. Moment of inertia represents the inertia of the rotor during sudden starts or stops. Maximum torque, measured in Newton meters. Maximum torque refers to the highest torque the motor can generate under rated voltage and frequency conditions. Response time. This is the time it takes for the motor to reach maximum torque after receiving an input signal. The shorter the response time, the faster the motor's reaction speed. Position accuracy. This describes the motor's ability to achieve precise positioning when combined with an encoder. Higher position accuracy indicates better control precision. Speed accuracy. This refers to the precision with which the motor can maintain the desired speed when working with an encoder. Higher speed accuracy results in smoother motor operation. These parameters collectively describe the performance and characteristics of an AC motor. Other optional parameters, such as torque characteristics, noise level, and axial load capacity, can also be considered depending on the specific application requirements. In summary, understanding and familiarizing yourself with the key parameters of AC motor is essential for selecting and using the motor correctly. Choosing the right motor parameters ensures smooth operation and enhances efficiency. Additionally, proper wiring methods are critical when using motor. Correct wiring ensures the motor runs efficiently and safely, increasing the performance and reliability of the equipment. Next, let's study the second part, the wiring principles of AC motor. AC motor generally have two wiring methods, star connection and delta connection. 1. Star connection. In a star connection, 3 coils are connected at one common point, forming a series circuit, with the power supply connected at the junction point. This wiring method increases the motor's resistance, resulting in a lower starting current when the motor is powered up. However, the motor's power output is also relatively lower. 2. Delta connection. In a delta connection, the 3 coils are connected end to end, forming a parallel circuit, with the power supply connected to two of the terminals. This configuration decreases the motor's resistance, leading to a higher starting current. However, the motor also produces more power compared to the star connection. Each wiring method has its advantages and disadvantages, and the appropriate method should be chosen based on the motor's specific operational requirements. Finally, let's study the third part: wiring methods for AC motor. The wiring method for an AC motor depends on the motor model and power supply voltage. There are common methods. 1. Single-phase motor. Single-phase motor have two wiring methods. Split-phase starting requires a starting capacitor and starting winding. Capacitor starting uses a running capacitor. Typically, the motor will have a connection box or terminal board with markings to help correctly connect the power lines and motor wires. 2. Three-phase motor. Three-phase motor can be wired in either star or delta configurations. Some motors may have a star-delta switch or terminal board with markings to help correctly connect the power lines and motor wires. It's important to check the motor's direction of rotation, which must match the direction of the power supply. 3. Bipolar motor. For bipolar motor, wiring is typically straightforward. You just need to connect the power lines and motor wires as per the markings. Regardless of the motor type, it's crucial to ensure the power is off before wiring. Double-check all connections for correctness and proper insulation. Have a professional handle the wiring. Today we covered the principles and methods of AC motor parameters and wiring. To summarize, the wiring method for electric motor is a critical aspect of industrial production. Proper wiring ensures that equipment runs smoothly, improving both production efficiency and safety. In practical applications, it is essential to select the correct wiring method based on the motor's model, rated voltage, and power. Strict adherence to wiring diagrams is crucial to avoid wiring errors that could lead to malfunctions. I hope you will apply the knowledge learned today in your future work and continue to improve your professional skills. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.